As I continued working on my end of semester project prototype, I came up with a few changes in my next version of the solar system implementation, which you can download right here. Let me show you. I will open the project. Okay, so it's now named Solar Vector. Open. I decided against adding new features. Instead, I wanted to improve the way I keep track of my planets before adding any new ones. So let's open the main file and take a look. So this is the new project directory named Lab 12 Solar Vector source file. So let's now open the main file to take a look. At the top, I have a new header file named Model Utilities, which we can see very soon. Notice also I renamed the project to maintain the correct path to the shader programs on the hard drive. But first, I decided to add a vector of models. Since we have global pointers to models, this is actually a vector of pointers to model objects. Next, I want you to see my new render function. And now, because now I have a vector of models, the rendering function suddenly collapsed into a much smaller implementation. I added a new function named config world, and then in a loop for each model, just simply here I update the view and perspective matrices in the vertex shader. Then I update the light position in the shader, and then render. All done. Two things I left unchanged is the original rendering for the skybox, which deserves some respect for its huge size and its special version of the view transformation. And finally, I also left here the spaceship drawing as well, because nothing has changed here since the original version. Next, in the main function, okay, over here, not that many changes except adding each model to the vector of models to keep track of them when we're rendering the frames of animation. And I also added a new implementation file to the project. It's named Model Utilities, together with its own header file. So let's look first at the header file to see what's going on here. To share my global variable declarations with the new utility functions, I declare all externally defined global variables right here using the extern keyword. This is a standard practice with C++ projects using multiple source files. And we also have here two new functions, load model and world configuration. So let's first try to locate load model and see how it's used in the main file. So this is our main file. And let's also open the implementation file for model utilities to look at them side by side. Load model, as you can see, creates new model, loads the object file, sets the material light, uploads the bitmap texture, uploads the model to OpenGL server. But this function is still unused. I am thinking it may be possible to start calling it in the future. And this is my world scene configuration function, which is invoked from our main rendering procedure right at the top. Okay, so when we invoke render, this is the call to config world. And you should see everything recognizable here. It's just simply for every pointer to a model object in the vector of models, or rather vector of pointers to models. I say that if this is a sun object model, then we configure the modeling matrix transformation for the sun model. And then, of course, if it's an Earth, then we do transformations related to the Earth model. And so this will be the new place for the next planet that I will be adding to my project. And then here's the Moon here on this list. And that's about it. So this is all I have here in the world configuration. Its responsibility is to set up the modeling matrix for each object in the solar system, and I find it a bit easier to handle it like this in a separate file. I recommend that you download this latest version available here at this link as your starting point to work on the solar system animation if you choose it for your end semester project.